So these are the same rules from last time. The product, the quotient, and the power. So what we did last time, we took something that looked like this on the left side of this equal sign, and we expanded it to where it looked like this, okay? So I would take something like the log base 2 of xy. When I expand it, that's what? Of x plus log base 2 of y. That's expanding it. What we're going to be doing today mostly is starting with something that looks like here on the right and condensing it to look like something on the left. So it's the same rules, but we're going to be condensing these logarithm expressions. So taking multiple logarithm expressions down to one, whereas what we did on the last lesson was one log expression, expanding it into multiple expressions. So product, quotient, and power. Correct. So let's look at it this way. Before we do that, these would have been homework problems similar to what you had from the 1.2. So I want to expand these. So expand these logarithm expressions. What do I see here? This is the log of what? Are those products, powers, or quotients? Power and product. So I've got x is raised to a power, but it's multiplied by 3. So I'm going to write this. This is the log base 2 of 3, and then what? Plus the log base 2 of x squared. Okay, that's as far as I can go with the 3, but when I look at the next one, that's x to a what? A power. Okay, so now the final answer here is going to be log base 2 of 3 plus what? Yeah, 2 log 2 of x. Okay, that's fully expanded. Okay, let's look at this one. Do you see products, powers, or quotients? You see powers because x is raised to the second power, but you also see a what? Quotient. It's 3 divided by x squared. So I can write this as the log base 9 of 3, and then what? What does the quotient rule tell me to do? Minus log base 9 of what? X squared. Okay. Now I've got log base 9 of 3. That's about as far as that can go. But if I look at the x squared, that's a product, power, or a quotient? That's a power. So this is going to be log base 9 of 3 minus what? Yeah, 2 log base 9 of x. Okay, so that's fully expanded. Now, the reason we spent that was so that you could learn the product, the power, and the quotient rule. The real reason we're really doing this is because it's a better skill to start with something like this and bring it down to one logarithm. We'll need that in order to solve some equations on Monday. So all I'm going to be doing today is in reverse, taking multiple log expressions and writing them as the log of one thing, getting it back to one expression. How do you think these could be combined into the log of one expression? Which rule? The product rule, okay? So if I look at it, if I use the product rule, this is going to be equal to the log base 4 of what? 6x, okay? That's all it is, just going backwards, okay? So yesterday's homework would have been, this is the problem, this is the answer. Today's homework, this is the problem, this is the answer. All we're doing is just going backwards, okay? So whenever I see two logarithms added, that implies it's the logarithm of the what? Their what? Their product. If I see two logarithms subtracted, that's going to be the logarithm of a quotient. If I see a number in front of a logarithm, that's going to be the logarithm of something to a power, okay? So here I'll use the quotient rule. This is going to be the log base 9 of what? X what? Nope. X over 4. Okay. See, Bella was absent. She's giving all the answers today. I don't know what's wrong with you guys. You know? You're so humble too. You know that helps. So. Okay, the next one. Product quotient. What do you think the next one is going to be? Power. So it's going to be the log base 5 of 3x to the what? 4th. Okay. Now, why did I not write the log base 5? Why did I not do that? Right, that means that it's only the x raised to the 4th power. So this is, when I move this coefficient and make it an exponent, everything is raised to the 4th power. So this is not correct, okay? So it's the log base 5 of 3x, all of that raised to the 4th power. Okay, so we're using those same 3 rules from yesterday. We're just going in reverse, okay? So again, product, quotient, and power. And so all we're doing is we're starting with problems that look like the right side, and then our answer is going to be what looks like on the left side of each of those equations. So let's get a few examples of working on these. Looking at this one, how do you think I could get that to be the log of one expression? It's going to be a quotient, okay, and a power. So which ones do I start with? Okay, I can't start with the quotient because I need to have the log of something minus the log of something. I've got 4 times the log of something and 2 times the log of something. What can I do to get it log of something minus log of something? Use the power first, okay? So this could be written as the log of what? X to the 4th minus the log of what? Y squared. Now I've got the log of something minus the log of something. That tells me to combine those, it will be a what? Quotient. It will be a quotient. This will be my numerator and this will be my denominator. So all of this is this is the log of x to the 4th divided by y squared. So now I have this as the log of one expression. Okay? Makes sense? So this was just combining the quotient and the power rule. Now, before we do the next one, the last class wasn't so good at this, but you guys have a chance to redeem yourself and them as well. Yeah. The log base b of b to the x is what? You haven't redeemed yourself yet. So the log base b of b to the x. Anyone?
Oh, it's x.
There you go. You halfway redeemed yourself. It's x.
No, the class is not redeemed.
What's the relationship between the exponential and the logarithm? They are what? What to each other? They are inverse functions. So what this means is you start with an x, and then you figure out what b to the x is. And then you turn around and you take the log base b of that. So b to the x takes you somewhere. Log base b will do what? It bring you right back where you started. This is x. This is the same thing as if I ask you, what's the cube root of x cubed? What is that? It's x. Anytime you cube something and then go take its cube root, you end up where you started, okay? So when you see something like this, the log base b of b to the x, it's x. I mean, what I told the other class, log base b of b, and I think I did this the other day, of whatever the heck, that's the G-rated version. If you need stronger language to help you remember that, that's up to you. Log base b to whatever the heck that is, that's your answer, okay? I don't care what is up there. Log base b of b to whatever. That's what this is equal to. Okay? Same thing if I do the if I do it in the opposite order, b raised to the log base b of x. What is that? That's x, okay? You don't need to spend a lot of time figuring this out. These are inverse functions. It's like if I add 3 and I subtract 3, where do I end up? Where I started. So like if I said x plus 3 minus 3 is what? What's x plus 3 minus 3? It's x, okay? Adding 3 and subtracting 3, those are inverse operations. Now, we're going to use that here. This is 6. What is the natural log? It's what? Log base what? E, okay? This is 6 times log base E of e to the x minus log base E of e to the 6, okay? Does everyone agree with that? That's all natural log means. Okay? Now, I want you to look at this. What is the log base E of e to the x? We talked to that about 60 seconds ago. What is it? Log base E of e to the x is x. What's the log base E of e to the 6? It's 6. That is just 6x minus 6, okay? So anytime you have the log base, it could be b, e, whatever, log base e of e to the 6, that's 6. Because e to the 6 is a function. And then log base e undoes that, okay? So this is the same as squaring something and then taking its square root. So a little bit tricky on this one, but you just need to recognize properties that inverses, the logarithms and the exponentials are inverses of each other. Okay? I feel like you're doing a little bit better with that. I'm trying to read the room here. Is this, I don't know why this is this a hard concept? Okay. This looks complicated. Log base e of e to the x. Just remember the logarithm and the exponential are inverse functions. Okay? If you need to think about it, log base e of e to something, these cancel each other. So this, the log base e and the e are going to cancel each other. This answer has to be x. Log base e of e to the 6th. The log and the exponential, they cancel each other. The answer has to be 6 in this case. Okay? Continue on. They get easier as we go, so we'll keep on going here. So let's look at this one. One of the first things I want to do is I don't want to let those minus signs confuse me in that parentheses. So why don't I distribute this negative sign and see what I have? So 4 log x minus 3 log y, and then what? Plus 2 log z. Okay? Now, I want to get this as the logarithm of one expression. Okay? What do you think I need to do first? Does this look like the log of something? Right. It looks like 4 times the log of something. So to get it to be the log of something, I'll use the power property. So this first one can be written as the log of what? X to the 4th minus what? The log of what? Y cubed, and then plus log of z squared. Now I have the log of something minus the log of something plus the log of something. Which rules will help me combine that into one logarithm? Quotient and product, okay? So this can be, anytime I see a plus, that means when I combine them, those two things will be what? They'll be multiplied or added or what? Anytime, so if I see a plus, let's just look at this. Log of x to the 4th plus log of z squared. When I combine those, the x to the 4th and the z squared will be what? Not divided. Starts with an m. Multiplied. And anytime I see a negative, that means I'm going to be, when I combine it, it will be a division. Okay? So when I combine this, this is going to be the log of x to the fourth times what? Z squared divided by y cubed. Okay. Now, in yesterday's homework, this would have been the starting problem. This would have been the final answer, one of these two, okay? So to expand this, this is the log of x to the fourth plus the log of z squared minus the log of y cubed. And then you could put those numbers, the powers, in front. So all we're doing is we're backtracking. We're starting with something that has multiple log expressions, combining it until I can get the log of one expression. And that's a skill we're going to need to be good on Monday when we start solving equations, okay? Taking things that look like this, getting them down to one expression. Let's look at the next one. So, what do you think the first step is to try to get this into one logarithm? Take care of the numbers in front of the logarithm, make those exponents. So this is the log base 2 of what? Yeah, log base 2 of x squared, and then plus the log base 2 of 1 over y to what power? Cubed, and then minus what? Yeah, log base 2 of z squared. Now I see the log of something plus the log of something minus the log of something. So I'm going to combine this. When I combine it, this and this will be what? Multiplied or divided? Multiplied. And then this will be divided. This will be the bottom of my fraction. So I'm going to get the log base 2 of x squared times 1 over y to what power? To the 3. All of that divided by what? Z squared. Okay. Now, I would have accepted this as a perfectly good answer. Okay. But because you've got this 1 over y cubed, you could have written it like this. Log base 2 of x squared over y cubed z squared. That would have been a perfectly good answer as well. So either one of these would have been good for the answer. You see what I did there? This is 1 cubed over y cubed, so I just moved it to the bottom. Either one of those would have been fine. Okay? Last year people felt like condensing was harder than expanding. What do you think? Why is it harder? Cole says it's easier, okay? It's just, you've got to be solid on the rules, okay? I mean, one of the things last year, I did them both in one lesson. Maybe that was made it harder. Today, I broke it up into 2 different lessons, or this year. And you guys are smarter than last year, so maybe that's it as well. So.
I don't know if Don would agree.
So, okay, let's keep going. Now, what's different about this one? Yeah, you got this xy. So, is there any logarithm being applied to this? No, it's just there for the ride, there to confuse you, make the problem harder, okay? But you're not going to fall for it. Okay, how do I convert this to the logarithm of one thing? This is the log of xy to what power? 4th. Minus the log of what? Xy to the 3rd. And all of that is just multiplied by xy, okay? Now, inside the parentheses, when I see the log of something minus the log of something, I know I'm going to use what? Quotient. So this is the log of xy to the 4th over xy to the 3rd. All of that is multiplied by what? Xy. Now we can do a little bit of simplification. What's xy to the 4th divided by xy to the third. xy. If you got 4 xy's on the top and 3 xy's on the bottom, what do you really have? 1 xy on the top. So this is just log of xy times xy. Okay. Now there is a shorter cut that you could have gotten to that answer without doing all of that work. This is 4 apples minus 3 apples. What is 4 apples minus 3 apples? 1 apple. So 4 log xy minus 3 log xy's is how many xy's? Log xy. So it's 1. So it's just log xy times xy. So that would have been just an easier step. 4 log xy's minus 3 log xy's is 1 log xy. So it's just log xy times xy. So you get the same answer. Okay. Either way there. Pardon me? Yeah, that's it. I mean, we're trying to get it down to one expression. Okay. There is a typo in your book on the next one. All of those are log base 3's. Okay. You can't combine. If this had been log base 3 and this is log base 10, I can't combine those. The bases have to be the same. So in your book, this next problem is all log base 3. Okay. So what do I do to get this combined into one log expression? Yeah, so first of all, this is going to be the log base 3 of what? Yeah, of x squared minus what? Yeah, log base 3 of y to the 4th plus the log base 3 of what? Z to the 1/2. Okay. Now I have log of something minus log of something plus log of something. I'm ready to combine with product and quotient. When I combine this, what's going to be on the top of the fraction? It's going to be the log of something, the log of a fraction. What's going to be on the top of that fraction? What, the x squared and what else? The z to the 1/2. What will be on the bottom of the fraction? Y to the 4th. Okay, so this is going to be the log base 3 of x squared z to the 1/2 divided by y to the 4th. Okay. Pretty straightforward, isn't it? Okay. So, nothing really new in terms of new rules. It's the same rules, product, quotients, and powers. So you really have to know those rules. I could ask you a homework problem like we did the day before where you take something and you expand it. Today's session was taking something that's already expanded into multiple log expressions, condensing it down to one expression. And we'll be using that skill on Monday to solve log equations. So you should be able to expand and condense log expressions. The other thing, guys, you have to know is something like this. The log base 2 of 2 to the x is what? It's x, okay? Log base 2 of, this is a 2. These are 2's. So the log base 2 of 2 to the x is x. The log base 3 of 3 to the f is what? It is f, okay? So you've got to know that. The log base 0.5 of 0.5 to the z is what? It's z, okay? So you've got to be able to recognize that, okay? Anytime you have the log base something of that number raised to a power, your answer is whatever that exponent is, okay? So be sure you recognize that. Okay, you should be able to get started on the homework.